Intake is new. We announced it on the Anaconda blog a couple of months ago, but it's a brand new project, and so I'm going to tell you what it's all about, and hopefully people will be interested and start using it. That's the reason for me to be here. So I'm employed by Anaconda. Anaconda supports this work, but it's free and open source, so anybody can contribute, anybody can make use of it. For this talk, I will first outline what I'm talking about, where intake fits in with the general idea of how people go in about getting at their data and using their data. And to give a bit more detail about that, I'm going to talk about some specific sets of populations, different kinds of people, and how they fit into the way that data gets around an organization. And then I'll talk about intake and what it does now, and what it can do in the future to smooth those processes of getting data to where it needs to be. That'll be followed by quick examples just to show how this might actually work. And then I'll wrap up with talking about what else is out there. So, first of all, I'd like to ask the room, how many people here think of themselves as primarily data scientists? Can I have hands up? We have a significant fraction. Any additional people who think of themselves as analysts or business intelligence or that kind of thing? A handful, okay. So I've come to the right place. I imagine lots of you will have seen code that looks something like this. This is in the context of getting data into pandas, which certainly in the Python world is the most popular thing for doing data science. You might pass data from pandas onto other things later, but pandas is a real engine, a real workhorse. So you probably have scripts or notebooks which have something like this at the top. You see the pointer? Yes. Okay. So this, for anybody that's used pandas, probably is fairly straightforward. I've perhaps overdone the example here a little, but you will have some of these things in some of your code cells. You have some files, CSV, very common, but you have to fetch them from some server. To do that, you need some credentials, and then you're going to load these into pandas and stick them together. Now you have a data frame. Now you can actually do your data science or simple aggregations or visualizations, whatever you're going to do with it. There are a few things that are questionable about this code cell. So I'm going to run through what different people might have to say about this. First of all, the data user. That is the person that's actually going to execute this cell and do something with the data frame. That might be an analyst or data scientist. All these things are difficult to define exactly what the different jobs are, so I'll just call it the data user. They're wondering, I just had to type all of this out. That's a huge waste of time. Why did I have to do that? Why do I have to figure this out every single time? On top of that, all I know about it is these file names. If I come back to this script in the future, I don't maybe know exactly what that stuff was. Does the file name tell me all that I need to know about my data? Probably not. Other people might look at this. So the data provider, that is the person who put those files in the place where you're going to access them, might say to you, hey, you are pointing to these files, but that's not actually the data set that you should be using. There's a newer one. Or in fact, the new version isn't in CSV at all. It's actually in something else. I have Avro as an example here. Oh, and it's stored on Azure. It's not on this server. You have to go through an API to get it. I'm using Azure because we're at Microsoft. It could be something else. Furthermore, IT somehow gets wind of this, and they say, what is this? Why are you doing this? It's totally against our rules. And in fact, they're not even your credentials. So this kind of stuff happens all the time. Now it's clear that this just got copied and pasted from somebody else's notebook, right? But it's just being used. That's not the best way to get data to where it needs to be. Then along comes the dev. Oh, I've heard that you're now dealing with Avro data next time, but Pandas actually doesn't read from Avro, so I'm going to have to write some stuff, but you can do that. Oh, and it's also on Azure. Yes, we're going to have to write some more code. So there are now 4 different people that I've mentioned here who are interacting over how to get this data into a data frame, which should be a pretty straightforward process. So with intake, this is the teaser. So we've gone through this in a lot of detail. You should be able to just do a one-liner like this. So obviously a lot of things are hidden, but from the data user's point of view, you just say, oh, I have some catalog somewhere. It may just be a local YAML file. It can be lots of things. We'll talk about that briefly later. And you just reference this file. The file itself defines some stuff, some spec, and then after that, you just say, I want this data set, and I'm going to read it. So this is the teaser. This is why intake can make things a lot simpler, but I'll go into a little bit more detail. So what really do these different people actually want when they are trying to talk about data and use data? This data user, so the person who's running the notebook, they want to know what data sets are out there. They want to know which of those do they actually need to use their job, to be able to do their job. So that means they need to know something about the data, some provenance, what is in it, some specification of what that thing is, and then they need to load it and do their job. So they want something that will just load the data and then get out of the way. The provider, they are making data for the users. By the way, these are not necessarily different people. I'm just saying, I know that there are individuals who might end up doing all of these jobs, but it's nevertheless useful to think about the specific things they're trying to achieve. So the data provider, they will know, because they're the ones that are making these files or data services, they know what's there, but they need to know everything about those data. They might have opinions over, as data comes in, what kinds of formats you should be using, how it should be partitioned. Those are the kinds of things that typically might be done by somebody with the title data engineer, but there are lots of people who might do that kind of thing. And then critically, if they don't happen to also be the user, they have to tell the user somehow that this data exists and it's in this format and you need to load it in this way. IT, as we said, also oversees all of these things and has a different set of concerns. They care about who can get to what data. They care about which data actually got accessed. They control the sets of identities across the system. And they probably are also acting as a gatekeeper for what data can be entered into the system as a whole. You might not have a dedicated IT team where you are, but if you're at a corporation that's large enough, you probably do, and they will do these things for you. And they usually don't like data scientists that go around saying, hey, I want this random data that you don't know anything about. And then there's the developer. Again, this is not necessarily a distinct, different person, but at some point, somebody will have to write code to load specific types of data. If it's CSV and you want pandas, then you're done. But there's a pretty good chance that it's something else, and somebody will actually have to write lines of code. But you don't want to repeat yourself. You certainly don't want to repeat what's been done elsewhere. You want the user to be able to use something that's familiar, that's the same every time. And let's say it's the Avro case. If you want to be able to write a read Avro function that returns data frames, you can make a separate package which you then have to distribute. You're probably not going to approach Pandas itself and say, hey, I have this new code and I want you to include it in your code base. Well, you might, but that won't get back to you fast enough for the user that actually wanted that code. Okay, so what does intake do? Intake talks to all of these points to some extent, but intake is supposed to be very simple, very lightweight thing that's pluggable so that you can add extra functionality as you go. At the moment, so here again is the data user with their set of concerns as we had before. So from the intake view, and this is the same code cell as before, you can open catalogs. So catalog from the user's point of view is some specification of a set of set of data sets. And you have an API on that, such as read and other things that I'll show you in the brief example later, that is going to tell you what that data is, and it will load the data without you not having to know anything about the specific set of libraries and functions that are being used in the backend. It's also going to handle the specific set of parameters that you need for that data set. That all gets saved into this catalog specification, which in the simplest case is just a YAML file. But you get other useful things along the way. You can use the GUI like this, which is not the most stylized thing in the world, but it's definitely usable. You have search options here. You can click through. You can examine, so you get some basic details about your data set over here, the currently selected thing. You can access quick plotting so that you can know some more detailed basic things about your data before you go and push it to your production cluster because you want to build your latest model. And then finally, the thing that we've seen multiple times is you can actually load it into pandas, for example, or other things, which I will mention. So pandas is a very useful workhorse, but it's not the only data that you might come across. Okay, data providers, as a reminder, these were their concerns before. So in the intake view, the data provider is creating these catalogs. And here is a YAML spec. So a complete catalog, which in this case has only one entry called entry 1. And this tells you everything that you need to know about a particular data set. So I can go through this in very quick description. You have some driver. This is basically what is this data. In this case, it's CSV. You have some description. So this is just free text so that the user can know something basic about your data. You have additional arbitrary metadata down here where you can encode anything that you like about your data. You might put tags in here. You might put creation time. You might put what set of files the data was originally based on. Some arguments that are going to get passed to the function, which is still the read CSV function, has to happen at some point along the way. And some user parameters. These are explicit things that you want your user to have a choice over. So for this data set, it's going to be some file that lives, in this case, in the same directory as where the catalog happens to be. And you're going to fill in this template thing with either the value 1 or 2, and the choice of which of those is left up to the user. So the provider here gets a lot of flexibility into how they describe the data. They really put all of the details down here. And so they don't need to direct the user. They just supply the spec, which is to be loaded by intake. From the IT person's point of view, then, again, now we have another catalog. This one has a few extra things in it. Now we're talking about credentials, which is the thing that annoyed the IT person the most before. So here we're loading from S3 in this particular case, and you will want some username and some password. I'm aware that S3 has a particular name for all of these things, but it could be any system, so I've made this fairly generic. So some username and some password. This again is using the templating system, and you have these user parameters. For one of these, for the username, you have some default, which is going to look up something in the user's environment, or it could be calling a shell script, or it could be doing something else to fill in that value, unless the user specifies their own value for it. For the password, there is no default. So for the password, the user has to supply something to the system, and then that will get filled in, and it will get passed to the backend when it's accessing the data. By the way, accessing data on S3 or Google or Azure or whatever is one of the things that comes for free with intake. So if you're using pandas to load CSV, then it can already do some of these things. But if you're loading some arbitrary other kinds of files, then from the catalog author's point of view, it's very convenient that you can get to these different file types, you can get to different file storage systems virtually transparently. So that's one of the bonuses from Intake. The developer, so the person who has to write lots of code, again, there are their concerns, and then here is what in the Intake language is called a driver. So Intake is a plugin system, so you can create extra functionality for Intake very easily. I know you can't, well, maybe the people at the front can actually read the code here, but this is a driver which is going to create data frames out of GitHub issues using the GitHub API. Maybe that is something that is useful to some people. This was done just as an example, but the point of it is that the amount of code that you need to get something done is actually very small. This, of course, relies on a third-party package that already knew how to connect to GitHub, so not all of the work is being done here, but there are lots and lots of packages out there that are like that, that deal with some specific data type, and they load it maybe into dictionaries or into something. So wrapping those things up so that it can produce data type that is actually useful for your data scientist is not quite trivial, but pretty easy, I'd like to say. So the developer can write something like this, and this, if you install it on your system, will get picked up by Intake, and it will be available at the time that you access your catalog. I'd like to claim that Intake is nice to work with. I'll leave it to those that try to tell me otherwise. And I encourage you all to have a look and to try to do these things. The more drivers for all of the different types of data that are out there, the better. And they will serve to make the Intake system more interesting overall. I'd also like to mention at this point that there are actually lots of different kinds of data out there that we usually don't think about as being data. These might be REST API, or it could be some other data service that you are connected into through your company that also provides data in various different forms. You can encapsulate all of these within data driver like this plugin thing here. And you can therefore expose them using catalogs so that your data users can use them without having to worry about all the details along the way. Okay, so I talked for quite a few minutes there. I'm going to show you quick walkthroughs of some of this. Before I do that, and I have a swig of water, are there any points to clarify at this moment?
How do I publish data?
There are multiple ways. The question for everyone was, how do you publish data? The simplest is to distribute this YAML file, which is problematic for some of the same reasons that the original cell was problematic. A better way to do the same thing, if you want to just stick with the simple YAML file spec, is to put that file in a shared place, obviously. But that shared place can again be on your favorite cloud storage medium. The point of that being that you can then update the file in place, and the people that reference that file to load data don't need to know that the spec has changed. Maybe it used to be CSV and now it's Avro. They just say .load, and they will get the data anyway. There is also a server, Intake server, which I'm not going to talk about in this presentation except to mention that it exists. So the Intake server is something that provides such specs, and there is an implementation that you can use now. But it's actually an opportunity. The Intake server is a very simple protocol, and you can write your own to do whatever you like. That's worth knowing about. Yeah, go ahead.
That's only for reading data, right? It's not for writing data as well.
Correct. There is no writing capability at the moment. It's something that has been mentioned lots of times, and maybe eventually we could think about doing that too. The reason that it would be possible is because the number of, we call them containers, so something like a data frame, the thing that you actually get out of it, there are relatively few of those. So they could be things like sequence of objects, array, data frame. X-array is the only other one that we have at the moment. So if there's a small number of them, then you could consider making a generic writing function for each of those. But there's a lot more input data types. So I don't know if you're familiar with Odo and other projects that try to do this kind of thing. If you're going from many to many, it's a really difficult job.
Well, so in the YAML file, you're mixing information that's more protected, like password, together with other more public configurations. I mean, in publishing those, is there a kind of nice, neat way to kind of hide the password information and publish everything else to people?
So there isn't a built-in encryption thing, if that's what you mean. But the example I showed used password credentials, but they weren't actually in the catalog. So yes, but probably not quite what you meant.
So then you just have to fill in yourself.
You have to fill in, or you have to get it from the environment or something else. I'm thinking we should get onto the examples now and perhaps come back to questions at the end. Is that okay?
I think we had one more up there too.
Okay, save your questions then. But we should be able to get through this fairly quickly, I should think, because some of this is repeating what you've already seen, because there isn't that much code from the, I'm calling it here data science because that was the most common grouping, but from the user of the data's point of view. So you import intake. And then in this case, I'm demonstrating that one way in which you can distribute your data, so I was just waiting to get to this, is actually to use Conda. So Conda is obviously quite popular as a way of distributing packages, but Conda can install anything, and it can also install catalogs. So you can try this out. There is an intake channel, which for the time being, the intake channel contains all of the intake material, and there are some example data sets there. So you can Conda install this, and what you get is data. So specifically, this shows up in this, if you've imported intake.cat is your installed data sets. And this US crime thing is one of the ones that's there. Obviously, I have a few more. And it is just the catalog entry, which actually is defined in a YAML file. It's just that YAML file, by Conda installing, has ended up in a special place. And then you can do the API, once you have one of these, is always the same. You can do describe, which is some basic information about that thing that's contained in the spec itself. So we have just a description here, and we know that it's going to output a data frame. You can put lots of other things in here. And you can also do discover. Discover involves actually accessing at least some of your data. So this is the next step. And it gives you something that is schema. In the case of a data frame, you have all these D types here. It's the basic information you would expect to see about a data frame. Exactly what you get will depend on the type of data that you're accessing. But it's nevertheless a detailed description of your data. And another thing that we notice is that we have some metadata here defining some plots. So in this case, because obviously I wrote this as an example, we also have some specific quick plots that are defined for us. So we can just get one of these. This one was called example, the first one. So you can just do dot plot. Dot plot by itself would create a generic plot of some sort, which in this case happens not to look very useful. I can show you if you're interested. But this specific example named quick plot has been defined in the spec so that you can investigate your data before deciding whether you do or don't want to go on and actually use it. Here's some crime stuff that I don't particularly know much about, but you can see that apparently burglaries were really high in 1980. In the US, I believe. And then you can get the data. So once you have the data, in this case it's a data frame, that's what the spec said it would be, you can do your normal pandas things to it. So I won't do the example there, there's not really much point. And then an interesting thing is this GUI, which again, you may choose to use if you're writing scripts. Obviously, you don't want to use a GUI, but often your exposure to data begins in the interactive phase where you want to find stuff and you want to know what's the useful one for the particular job that you're doing. So these are the built-in ones, which includes the crime thing, which is this is the same information that was given by describe above, but there are some other things in here. For each of these, you can click on it and you can just access it as GUI.item, so then you can go and work with it. So here is some Minis images, and it tells us that this set of images has this shape because they're little square things and there's lots of them, and you have D-type. You see that the information that you get back about your data is a bit different for an array type thing as opposed to a data frame type thing, but that's fine. We understand what that means. In this case, there's also an additional thing that this will actually cache some data locally. There's some extra features that are hidden under the hood here that as the data user, you actually don't need to know about. In addition, you can add extra catalogs to here, or you can have them automatically added for you, but I just wanted to demonstrate. This is the catalog for the Pangeo project, which is using intake, and you can open it. The name here, by the way, is just the name of the file that I accessed, and they have several catalogs of scientific, earth science and climate stuff on there that I'm not going to read. These are all X-ray things if you're interested. And furthermore, you can have catalogs that contain other catalogs and you can search amongst them. So there's a whole range of interesting things that you can get into here. In the interests of time, though, I'll go and look at the other side of this, which is just creating these catalogs is a thing that somebody needs to do. Unless you're using the small number of example data sets that are out there. So intake, if you've installed some of the drivers, may have lots of things that it already knows how to read. And you can use these open functions, like again, let's start with CSV, to open some CSV file. This one happens to be a remote one. And this is very much like just doing the same thing with pandas. But I'm making a source out of it so that I can do some auto-discovery on the thing, and we can see it has some D-types or whatever. This is not particularly interesting thing to do, but it's something that when you're creating your catalog, you will want to know that a particular file does load and that it does contain what you expect it to contain. So you can do that, and there it has some stuff. And you can also be interested in what kind of plots you can make with your data. This is just some example. This is using hollow plots and HV plots. This package, which is part of PyViz, if anybody's been following that stuff. But it's the kind of parameters here that you might expect. The point of doing all of that is that once you have it, you can take this source thing and generate the YAML for you, and you can put this into a catalog. Obviously, this has no description. We haven't given it yet. When you actually make the file, when you actually make the catalog, you would want to fill in the metadata and descriptions here and anything else that you want your user to know about. And in fact, you want to include this plot stuff in here too. This is exactly the same thing as is above, except that it now has a description and I filled in a plot. So then you can check it, you can open that catalog, and again, the plot is identical to how it was before. It's just an encoding of the work that as the data provider you've had to do to figure out what this data is, so then it's saved in a single reference place and you don't end up copy and pasting, you can just refer to it. And you can then put it somewhere remote again. So this is again the same data set, except that now it's at some HTTP address so that it can be accessed by anybody. Or you can make a conda package, which I'm not going to cover today. So that's it for examples. I'm not going to talk about the server, as I mentioned. I'm not going to talk about how you write a new driver or other plugin to go into intake. You will have to read the documentation for that. But I'd like to think that it's approachable. And again, there's issues for you to file if you don't think so. Now, briefly, I just want to mention that there are lots of other things out there in the data sphere. You've seen all of these logos. Some of you work with these things. Some of you are employed by these people. And it's a crowded space. And, oops, sorry. And they all do some part of this thing. Some of them do more than others. They have different focuses to them. I don't need to go through this in particular, but there is one interesting point is that SQL, like tabular things, is by far and away the most common data type that's out there, and it's the most common data type that data scientists will use. But actually, there's a whole other world of data things out there that is rarely referenced, but worth bearing in mind. And I don't just mean arrays either, but arrays themselves are very useful. So I have a slightly questionable grid of features here. This is not really features. Most of these things that are listed on the left can do more than where I put the X. They definitely can do more than where I put the X. But this is my personal feeling for what the main focus is of the different things, depending on the front page of the appropriate website. So it's not deep research here. And there are some interesting things. There are lots of different entities, but they all have different particular focuses. This is not surprising. The point of intake is to try to be generalist, to try to be very lightweight and plug into other things rather than trying to reinvent a monolithic thing by itself. So it's not going to host your data for you. It's not going to be your credential system. You have to figure those things out for yourself, but you can plug them into intake. That's the idea. That's why it should be simpler. So this is basically the end of the talk. So just to summarize, the main ideas of intake is that your users get an API that's easy to use, and it's always the same, regardless of how the data is actually stored. You have catalogs. Catalogs are really useful. You should already have catalogs, but you probably don't. Or you only have catalogs for some specific parts of your data ecosystem. It separates out the people that provide the data and understand in detail what that data is from those that use the data and don't want to know that stuff, don't want to have to write code or anything like that. They want to do their work, which is making inferences, making models. You get to access your catalogs and data on various cloud sources. This is very important these days, so this will integrate with multiple file system-like backends. You can extend intake very easily. There is a server which is particularly useful perhaps in the corporate setting where you have to care about logging who has accessed what and that kind of thing. And it integrates with other things around the PyData ecosystem. So the plotting, the Conda, Dask I haven't mentioned. I also work on Dask, so that's a thing that's interesting for me. That most of these data, when you load them, there is a single method call to turn that thing into a Dask thing so that you can work on it in parallel on a cluster if you want to. Again, we can talk about that after. But the main message is that people should try it and give feedback. This is new, it's young, there's lots of scope to move in whatever direction people feel is interesting. So I'll end there.
I think we can have, a couple of questions.
Hi, this looks awesome. Thank you very much. Quick question. Did I get it right that the Conda packages don't actually contain the data, they contain the catalog that gets you to the data?
They can contain the data. So if it's something small, if it's some reference material that is some definitions, then yes, you definitely can include it directly in the Conda package. More normally, it will be just a catalog that points to some other external resource, but you also have the caching ability to enable you to have a local copy on first access, which is useful for some situations.
Thank you.
Sorry, there was a guy.
Do you have some kind of like deltas? Because a lot of times what winds up happening is that, either the file gets updated, like the same file, or it's, you want to connect to a database instead of just a CSV file. Well, is there some concept of deltas where you can pick up based on maybe some kind of day or something else?
NumFOCUS is pretty much agnostic to how you lay out your data. If you have a system that already does that, to have main data plus deltas, then intake can be, you can write a driver to use it, but there's nothing built in to do that.
You mentioned some templating, and I was just wondering how you model like various dimensions. If you have a data container that may vend things by date or by country or region, is that kind of built into your model of a data set?
There are a couple of separate things. So the templating I was talking about was how you define the parameters for loading. But there is exactly what you're saying, interpreting file names or directory structure so that you can get that information out upon loading. That is also something that explicitly exists for a couple of the drivers so far. But yeah, the code to do it is in intake itself. So if you wanted other drivers to support that, then it would be trivial to set up.
Right. Thank you, everyone.